The National Electrical Code, specifically Article 250.4, deals with the bonding of electrically conductive materials that are likely to become energized. Bonding ensures electrical continuity and creates a low-impedance path for fault current to facilitate the operation of overcurrent protective devices. This helps to minimize the risk of electrical shock and fire hazards. Bonding connects conductive parts together, creating an electrically conductive path that can safely carry fault current back to the source. This is typically achieved using bonding jumpers or other approved bonding methods. The purpose of bonding is to equalize the electrical potential between different conductive parts, reducing the likelihood of a voltage difference that could pose a shock hazard. However, the question pertains to whether the National Electrical Code addresses grounding specifically for the purpose of dissipating static electricity from conductive, metal devices that are part of a building's structure or systems. Grounding and bonding are distinct concepts in electrical safety. Grounding refers to connecting a conductive object to the earth, typically through a grounding electrode system. The purpose of grounding is to provide a reference point for the electrical system and to help stabilize voltage during normal operation. It also provides a path for fault current in the event of a ground fault. Static electricity, on the other hand, is the buildup of electrical charge on the surface of an object. This charge can accumulate due to friction, induction, or other means. When a statically charged object comes into contact with another object with a different electrical potential, a discharge can occur, resulting in a spark or shock. While the National Electrical Code extensively covers grounding and bonding requirements for electrical systems to ensure safety related to fault currents and voltage stabilization, it does not explicitly address grounding for the sole purpose of dissipating static electricity from metal devices within a building. The code primarily focuses on the safety of electrical systems and the protection of people and property from electrical hazards associated with the normal operation and fault conditions of electrical circuits. Static electricity is often considered more of an environmental or operational concern than a direct electrical safety hazard addressed by the National Electrical Code in the same manner as power system grounding. There are specific instances where the National Electrical Code addresses static electricity indirectly, especially in hazardous locations where the accumulation of static charge could create a spark and ignite flammable materials. In such cases, specific grounding and bonding requirements are put in place to minimize the risk of static discharge. These requirements are generally found in Article 500.505 and related articles of the National Electrical Code, which deal with hazardous locations. However, these requirements are specifically tailored to address the risk of ignition in areas where flammable gases, vapors, or dusts are present. For general building applications, where the primary concern is the nuisance or discomfort caused by static shocks rather than a significant safety hazard, the National Electrical Code does not provide specific guidance on grounding for static dissipation. Instead, other methods are typically employed to control static electricity, such as the use of anti-static mats, sprays, or grounding straps. These methods are designed to reduce the buildup of static charge on surfaces and prevent static discharge events. In summary, while the National Electrical Code extensively covers grounding and bonding for electrical safety purposes, it does not specifically address grounding solely for the purpose of dissipating static electricity from metal devices in general building applications. The code focuses on protecting against electrical shock and fire hazards related to electrical systems, while static electricity is typically addressed through other means, especially in non-hazardous locations. In hazardous locations, the National Electrical Code does address static electricity indirectly by requiring special bonding and grounding to prevent ignitions. It is important to distinguish between grounding for electrical safety, as covered by the National Electrical Code, and methods used to control static electricity, which are often addressed through separate standards and practices. Grounding for electrical safety is intended to provide a path for fault current and stabilize voltage, while static control methods are aimed at preventing the buildup and discharge of static electricity. The National Electrical Code defines grounding as a conductive connection, whether intentional or accidental, by which an electrical circuit or equipment is connected to the earth or to some conductive body of extended extent that serves instead of the earth. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. Grounding also helps to stabilize voltage and prevent excessive voltage fluctuations. Bonding, on the other hand, is defined as the permanent joining of metallic parts to form an electrically conductive path that will ensure electrical continuity and the capacity to conduct safely any current likely to be imposed. Bonding is used to connect different metal parts together, such as metal conduit, equipment enclosures, and structural steel, to create a continuous electrical path. This helps to equalize the electrical potential between different metal parts, reducing the risk of electrical shock. The National Electrical Code provides detailed requirements for grounding and bonding in Article 250. This article covers the types of grounding systems, grounding electrode requirements, grounding conductor sizing, and bonding methods. The requirements vary depending on the type of electrical system, the size of the equipment, and the location of the installation. For example, the National Electrical Code requires that all metal enclosures containing electrical equipment be grounded. This includes enclosures for panel boards, transformers, and motor controllers. The grounding conductor must be sized according to the size of the overcurrent protection device protecting the circuit. The National Electrical Code also requires that all metal water piping systems be bonded to the electrical grounding system. This is to prevent the water piping from becoming energized in the event of a ground fault. The bonding conductor must be sized according to the size of the service entrance conductors. In addition to the general grounding and bonding requirements in Article 250, the National Electrical Code also contains specific requirements for grounding and bonding in different types of occupancies and installations. For example, Article 547 covers agricultural buildings, Article 550 covers mobile homes, and Article 680 covers swimming pools. These articles contain specific requirements for grounding and bonding to address the unique electrical hazards associated with these types of occupancies and installations. Static electricity is a different phenomenon than electrical current flow in a circuit. Static electricity is the buildup of electrical charge on the surface of an object. This charge can accumulate due to friction, induction, or other means. When a statically charged object comes into contact with another object with a different electrical potential, a discharge can occur, resulting in a spark or shock. Static electricity is more common in dry environments, where there is less moisture in the air to dissipate the charge. Static electricity can be a nuisance in many settings, causing discomfort or interfering with sensitive electronic equipment. In some cases, static electricity can also be a safety hazard, particularly in environments where flammable materials are present. In these cases, a static discharge can ignite the flammable materials and cause a fire or explosion. There are a number of methods that can be used to control static electricity. These methods include increasing humidity, using anti-static sprays, and grounding conductive objects. Increasing humidity can help to dissipate static charge by providing a path for the charge to flow to ground. Anti-static sprays can be applied to surfaces to reduce the buildup of static charge. Grounding conductive objects can provide a path for static charge to flow to ground, preventing a buildup of charge. In summary, while the National Electrical Code extensively covers grounding and bonding for electrical safety purposes, it does not specifically address grounding solely for the purpose of dissipating static electricity from metal devices in general building applications. The code focuses on protecting against electrical shock and fire hazards related to electrical systems, while static electricity is typically addressed through other means, especially in non-hazardous locations.